numbers 1 and 2 together. There's that. If on the off chance you're, looking back on this video, reviewing this material, here's numbers 1 and 2, but we're not going to talk about those. We're going to talk about 3 and 4, and we'll see how far we can get. We're not going to go through all of them. We don't have that much time, but we'll see what we can do. So, number 3, what relationship do we have here, folks? Complementary, that's right. Complementary. And we know this is complementary because of this little square here. That little square gives it away every single time that we have a complementary relationship. Because what does that square tell us? That we've got a right angle. And how many degrees is a right angle? 90 degrees, that's right. So again, question 2 is pretty self-explanatory. We're going to add together these two quantities. 41 plus 2x plus 1 equals 90. What like terms can we combine on the left-hand side here?
41 and 1.
41 and 1. We'll take those and make 42. So we got 42 plus 2x equals 90. What's next? We're going to subtract. What are we going to subtract? 2x?
No, 42.
No, we're going to subtract 42. Because our number on the right is a constant term. We're going to want to combine it with its like term, which is another constant term, or a number. 90 minus 42 gives us 48. We divide by 2 and get what? 24, that's right. Do we need degrees on our answer here?
No.
Why not? That's right, because we found the variable. Okay, guys, let's simmer down a little bit. We don't need degrees on our answer because we found the missing variable, but we didn't find the actual angle measure. So don't worry about degrees if you're just solving for x. All right, what type of relationship do we have in number 4? Supplementary, good. How do we know this is supplementary? Just like the warm-up? Because it forms a straight line. Here's 3x plus 8. There's 109. We can see clearly that together, those two angles form that nice straight angle. So we'll add them up, 3x plus 8 plus 109. And what are we going to set it equal to? 180 this time. This is why it's important to identify what relationship we have, because you might just go autopilot and set everything equal to 90. But that's only going to happen in 33% of the time. So here we've got supplementary. We're going to set it equal to 180. Let's once again combine these like terms. 8 plus 109 gives us, what is that? Good, 117 equals 180. Oh, forgot to split my equation. There we go. What are we going to do next? Are we going to divide both sides by 3? That's right. Before we divide by 3, we got to subtract 117 from both sides, leaving us with, what is that, 63? Good, great job. And then when we divide both sides by 3, what are we left with? 21, that's right. 9 plus 10. So, complementary, supplementary. Let's go to number 5. Because what's the relationship here in number 5? Vertical angles. Let's draw our angle markers here. There's 52. There's 3x plus 1. And we can tell right away these angle markers do not touch. Right? Back up to number 4. The angle markers touched right there. And we didn't draw them for number 3, but if we did, we would see that they also touch right there on that center line. But these angle markers are on opposite sides of our diagram. So right away we know these are vertical angles. Now we're going to do this equation set up a little bit differently for vertical angles, right? What are we going to do? That's right, Noah. We're going to set these two quantities equal to each other. Because what do we know about vertical angles? They equal each other. Remember the term for that? There we go, congruent, right? So if this side is 52, This side also has to be 52. So we can say that 3x plus 1 is equal to 52. Now this is really different from complementary and supplementary, where we add them together. So I don't want you to assume every single time we need to add together, because when that vertical angle pair gets thrown in, we have to know what we're doing. And that's just setting both quantities equal. We'll subtract 1 from both sides to get 3x equals 51, and we'll divide by 3 to get x equals 17. Sounds about right. Give me a thumbs up. Anyone else get 17 on number 5? All right, I believe you. 17. No degrees needed. Over to number 6. What type of relationship do we have here? We see that little square. What does that mean? Complementary. That's right. We could just say COMP. Don't need to spell that whole thing. 30 plus 2x equals 90. We'll subtract 30 from both sides to get 2x equals 60. So what's my x going to have to be?
30.
That's right, 30. Great job. You guys are killing this. All right, let's flip this thing over to number 7. So we got 12 problems left. We don't have time to do 12 problems. Was there anything on 7 through 18? Was there any problems that had you guys confused? I want to make sure that we attack specific problems here as opposed to just blanketing over the whole thing. Does anyone have a problem they want to see gone over before we just go for it? No, we must have these all done and complete and correct then. That's great. So I want to give you guys a chance to check your work. So let's take a look at the answer key here. There's the first 4 on the second page. 25, 26, 9, and 18. Go ahead and use your red pens to check those 4 off. Make sure your answers look right. If you got something different, take a look at what I set up for my equation and compare it with yours. See, well, did I set this up right? Maybe you added them together when you should have set them equal, right? But take a look. We'll take like 60 seconds to try and spot any problems that we have in those first 4. I know it's kind of hard to see if you're in the back. I'll try. That's as good as I can make it, unfortunately. Skipping past 7 and 8, we'll look at the bottom 4. If you got 46 and 23
Wait, what?
on number 11 and 12.
Oh, no.
Oh, yeah, we're still on. There you go. Yeah, you got it. 46, 23. Questions on page 2? We're all checking our work, right? Making sure it looks good?
Yep.
Okay, I trust you. Flipping over to 13. I'm going to go 2 by 2 here just so people in the back can see this a little bit better to check their work. There's 13 and 14 for you. And I skipped over the whole like writing out the subtracting from both sides and dividing because that's kind of self-explanatory at this point. But if you're confused as to what I did here, all you got to do is ask. I'd be more than willing to explain. But take a look at your work and make sure it matches mine. Let's go down to 15 and 16. If you got 53 and 34, then you did great. You got something different. Again, take a look at your work, take a look at mine. What's up?
Number 16, vertical and subject.
Number 16? Vertical, because they're directly across from each other. Here, let me show you. If we draw the little angle marker here for 2x plus 1, and we do the one right here for 69 degrees, they're directly opposite of each other. These 2 little curved lines do not touch at all, so that's how we know they're vertical angles. Great question. Verticals, it's like it's the easiest to solve in my opinion, but it's the hardest to point out. You guys agree with that?
Yeah.
A little bit? Okay, cool. We're going to see a little bit more of vertical angles today with our notes. Hopefully it'll clear things up. If not, we can always talk about it more. And finally, 17 and 18, we'll close it out here with 23 and 16. I think it's 16, right? Okay. I messed my answer up somehow. I forget what I did. We got complementary and supplementary. So if that all looks good to you, you feel confident in your work, go ahead and give it to whoever's in seat number 1. I'll come by and grab those. And we can get our notebooks out and get ready for note sheet number 3.